These notes are on long division of rational functions. Long division was actually a topic that we covered in Module 3, but we just kind of want to remind ourselves about it again because we're going to be using it very heavily and in a slightly different way in this module. So the first thing I want to point out with both of these examples is that both of these are improper fractions. Which means they're top-heavy. It means that there's a bigger number on the top than on the bottom of my rational expression. So 1, that means I can do long division. 2, it means that I could possibly get a remainder. So let's just remind ourselves. If I was to divide 2 into 89, I would say 2 into 8, 4 times 8. Subtract, carry down, 4, 2 times 4 is 8, subtract, carry down. So that we could actually say that 89 divided by 2 equals 44 plus 1/2. So now let's look at that same process with our rational function. So I set up my long division, x squared minus 2x plus 1 divided into x cubed plus 3x squared. Oh, there's no x term, so let's fill that in as 0x. It may just make my life a little easier as I'm doing this process. So we ask ourselves, how many more x's do I need in order for x squared to be x cubed? It's just x. So I distribute the x. I get x cubed minus 2x squared plus x. And then comes the part where I actually take out a different color pen because I really want to make sure that I am going through and actually subtracting each and every piece. That's what makes the x cubes cancel. That's the process that we did right here where we said 8 minus 8. You may have forgotten that you were minusing because you do it so quickly now and your brain is already sort of accustomed to that part happening sort of hidden, but we really want to make sure that we're clear that that is what is happening. So now I've got 5x squared minus x. So, and I can bring down my plus 7. So now I have to say, well, what do I have to multiply x squared by to get 5x squared? Well, that would be 5. So I distribute 5x squared minus 10x plus 5. Again, my different color pen, subtract, subtract, subtract. Get 9x plus 2. And I can't go any further. It turns out that I can't really multiply x squared by something to get 9x. I mean, I guess I could multiply by x over 9. So I now can sort of finish my problem. I have a remainder. So we would say that f of x equals not just this, but we could also write this as x plus 5 plus 9x plus 2 all over x squared minus 2x plus 1. And we can see the analogous relationship, over here, where we said that 89 over 2 was 44 plus 1/2, the remainder over what I am dividing by, so the remainder over what I am dividing by. And for now, I'll just leave the x plus 5 in parentheses. It doesn't need to be, but at least then it kind of distinguishes what it is that I have set up here. So let's look at a second example. Again, I'm going to set up the exact same process. This time it may be a little longer or easier maybe. I'm missing an x squared and I'm also missing an x. So we're going to fill those in as zeros. What times x gives me x to the 5th, x to the 4th, x to the 5th minus x to the 4th. Subtract, subtract. Oh, everything cancels. So I can just bring down my 3x cubed plus 0x squared plus 0x plus 10. So now I'm all the way over here. What I need is a 3x squared. And you'll notice I skipped this spot right here because I'm not doing an x cubed, and it just kind of reminds me that two things canceled, that I'm moving straight on to how to multiply x by to get 3x cubed. So distribute 3x cubed minus 3x squared. Subtract. 3x squared plus 0x plus 10. That's going to be 3x squared minus 3x. Subtract. 3x plus 10 plus 3x minus 3. Subtract. 13. So I can rewrite my g of x now as x to the fourth plus 3x squared plus 3x plus 3 plus 13 over x minus 1.